do you think optimistic rollups still have a chance? Yes or no?
Still have a chance. Okay, interesting question. Yes, but I don't know the entirety of the scope of the question, but I'm gonna just say yes, and we'll default to that.
Do optimistic rollups still have a chance? Optimistic rollups are aging tech, they have a 7-day finality window, and ZK is more efficient, but Nick Dodson from Fuel Labs argues, yes they do. They're more practical, faster, and cheaper than ZK rollups. He goes through how we can solve the 7-day finality window with a finality gadget, goes through the history and design choices on how Fuel differentiates itself. Like for example, how Fuel doesn't use the EVM, but its own programming language, say, for its execution to be parallelized. Let's get to it. Okay, so there's this idea of like optimistic rollups kind of being like baggage, like emotional, like, spent all this time, did all this work, funded, millions of dollars, have all these projects, invested in all this code, and like it sort of is, people say, at least the ZK people say, it's sort of emotional baggage from the Ethereum community. Do you think that is true? Just what's your general opinions as someone who is building an optimistic rollup?
Yeah, I mean, I think that. Calling it emotional baggage is like very. I don't know. That seems pretty obtuse. I would just say that optimistic rollups are a nice venue to explore a lot of the architecture that we want to see on Ethereum, and right now, it's still far more efficient to use an optimistic rollup than it is to use a ZK rollup in terms of processing cost. So DA cost has basically plummeted. So now it's down to whatever you're going to pay outside of DA cost. And right now, the cost for us in execution to process transactions in an optimistic rollup is very low. It's basically, you could say, almost free. So there are limits and constraints on the way certain optimistic rollups are designed right now. So if you're using an EVM or using a gas metered system, there's only going to be so much you can handle in terms of what you can charge, but effectively it's free to run almost. So yeah, I mean, you can say like optimistic rollups are like a stepping stone to a lot of scaling. I'd love everything to be ZK related, or powered by ZK in some way. But it's just really, really expensive to do that. And I think that there is a lot more ZK than there was maybe 4 or 5 years ago. So, and we're seeing some stuff get to production. So that's really exciting. But I think that ZK still has enormous overhead in terms of cost versus just actually verifying the transaction once. So I would say that optimistic rollups, whether ZK people like it or not, are going to be around for a very long time, given the fact that it's very hard to compete with almost free. So, yeah.
So your argument is more around just practicality and how ZK rollups are pretty expensive right now. If the ZK tech were to improve, would you ever use a ZK tech?
Yeah, I mean, we use ZK already in a lot of different areas of our architecture right now. So our proving for fraud proving will use ZK. So our fraud proving will use ZK. A lot of proof compression that we'll do will use ZK. We try to apply ZK basically in a bunch of different areas in our architecture already. I love a lot of the stuff that's going on, but I also know how extremely computationally expensive it is to process all this stuff. And even if the overhead is only 2 to 4x over an optimistic rollup, that's still 2 to 4x more for every single project that you want to use it. And if I can offer a project, 5,000 TPS and they don't need to use ZK, and they don't need to pay that proving cost, there's a high likelihood they'll just do that instead of doing a ZK rollup itself. So there's still ways to go, I would say, in order to make ZK economical for high throughput rollups. For low throughput rollups, maybe it makes a little more sense, but for high throughput, it's very difficult right now to make everything ZK. At least for the next few years. I think it will change over time, but the way that Fuel is designed is such that a lot of our processing can be done in advance and in parallel. So it's actually useful for optimistic verification and syncing, but it's also useful for ZK block building. So if you convert Fuel into a ZK, we would have way more opportunities to parallelize and get ahead of processing transactions than basically every other architecture because of the way Fuel's designed. So for us, we've always been planning for sort of a ZK oriented future. It's just for us, it's not really the best time right now because it's still too expensive for us. Yeah.
Also, there is this problem with optimistic rollups with the 7-day contesting period. You were talking about there's this paper which would solve that problem and give sort of this like instant finality. Could you talk about that?
Yeah, so we published something in ETH Research and on Fuel Forum, which is describing what we call our Snap finality gadget. And the idea there is that basically there is a technique to apply what would be a or retain a honest minority assumption in an optimistic rollup, allow a permissionless validator set, but with some staking and bonding, basically allow people to shrink that finality window down to something like 1 Ethereum block. And the way that that's done is you basically allow the permissionless validator set to vote constantly. If they miss a vote, then that's deemed as sort of censorship, or that's deemed as literally the network's trying to censor them. And then the window expands passively up to 7 days. But in the optimistic case, if everyone's voting, you can basically bring that down to the shortest possible span you can think of. So that mechanism gives a pathway to doing faster finality for optimistic rollups. One way that that can be applied also is in a hybrid format. So instead of doing your whole optimistic rollup as that fast snap finality gadget, you could do a portion of your liquidity under that snap finality gadget. And then basically you would still have the 7-day window for a large chunk of your liquidity, but a certain chunk of the liquidity can go under this fast finality gadget, and then that helps market makers rebalance in a much more efficient way. And then when you're allowing sort of market makers to basically play a part in that and rebalance, then you're sort of in a really nice spot, because then you don't really care so much about the 7-day finality window. You're being bailed out by liquidity providers all over the place and sort of clearing markets. So there's hybrid models of what we propose, and then there's also like trying to apply that to the whole rollup. Yeah.
Mm-hmm. So you have this validator set that then bonds these tokens, some sort of stake. I guess you could also do like restaking, and then they can trace the transactions. They can execute them and understand like this one's not going to be this one's valid, and they could sort of agree to skip the 7-day optimistic period by tracking these votes. And if it starts to become inconsistent, then you know that someone's being censored, and that's how you can lower the finality time. Is that it?
Yeah, so the primary reason why the finality window is 7 days is because you want to leave enough time for someone to submit the start of a fraud proving challenge, right? And so if you don't leave enough time, then basically someone could fill up all the blocks with a bunch of spam, and it'd be very hard to get your fraud proving challenge started. And so that's why we kept it at 7 days. Now, in theory, it's probably safe to lower it to 1 day, because to censor Ethereum, even for a whole day, is so expensive that basically I wouldn't count on any one particular party actually even censoring anything for 1 day. So just before we even get to the gadget, you can probably already lower it to about 1 day and you'd be totally fine. But outside of that, let's say we retain the 7 days, because then it's the cost of censoring Ethereum for 7 days, which is an enormous effort. And by the way, the chain would likely react and fork, against those attackers under that kind of attack anyway. So I don't really think something like that is even feasible, even if it's 1 day. But I think the idea is that 7 days is really safe. So now let's assume for a second that you had a bunch of rollup validators, and they're validating a rollup. What they do is they constantly submit votes, and if all the votes come in, then you can just assume that because it's a permissionless set, that effectively all that state that's been occurred, every state transition, all of those are valid, because every single party had a chance to vote and they all voted that everything is valid. But in the chance that any one of those parties decides, hey, you know what, I don't think it's valid, they can go in and not vote and they can submit a fraud proof. Now, if they don't vote, they're also signaling that they could be being censored. And that allows you to expand the window out because you're using that as the mechanism to expand the window, because that's the only mechanism you have in Ethereum outside of doing something is not doing something to actually flag that censorship is happening. Now, the one thing that is more of a limitation of this mechanism is trying to do this with reliable liveness. So basically, trying to get everyone to vote. And if they don't vote, what really happens and what is the punishment? Yes, the finality window expands to 7 days. More people have time to think and submit a fraud proof, but you can have a griefing vector. So you want to set the economic bonding for liveness such that bounds in certain windows, you have the right economics and the right bonding. And that's why I was saying before that basically for a roll up itself, parties that would probably want to be a part of this are people like market makers, liquidity providers. They have a lot of liquidity. They'd be happy to stake a large amount for liveness. And basically, they would be the direct beneficiaries of this mechanism. So by having people like that be a part of your roll up and stake, basically means that you can have high bonds, but it's only for this certain section of liquidity in your rollup anyway, and there's a big bond on it. For the rest of it, it just runs like a normal 7-day optimistic rollup, and you can submit fraud proofs as normal, etc. And that's virtually free to validate and virtually free to submit a challenge. I think maybe the key idea to explore with the fast finality gadget itself, or something that maybe is most pertinent, is that the biggest problem right now for faster finality for optimistic rollups is not for necessarily users. It's for liquidity providers rebalancing between optimistic rollups, because they're the ones that actually need to use the 7-day canonical bridge. Users can typically use any bridge that they want to immediately sort of exit their liquidity to wherever they want to go. So essentially, this is more a problem for capital and liquidity providers, and not so much for users. And so, with that being said, if I could, for a certain chunk of the liquidity in rolling 7-day windows, basically allow that liquidity to have a fast exit out of optimistic rollups and between each other, then that way liquidity providers have a way to rebalance and use that facility, while regular users will just use normal bridges. And that really alleviates maybe 80 to 90% of the capital inefficiency that's caused by the 7-day window in the first place. So basically, the fast finality gadget we proposed, which is up on ETH Research, the Why Wait a Week post, that outlines like the core ideas. And then because it does require some higher bonding, it's most likely the case that higher bonding would be the roll-up operators themselves, and most likely some liquidity providers. And then they would be the ones that would also directly benefit basically from having the liquidity move out faster. So they're the ones that are more than happy to put up, a high bond for one of these popular optimistic rollups. So that's kind of the idea, is that you can kind of create a slow and fast lane for canonical bridge withdrawals out of optimistic rollups. And that really, I think, solves an enormous amount of the current inefficiencies that you see with optimistic rollups in general.
I guess let's also talk about the fraud proofs themselves. So you're talking about sort of these, what do they call it? Some games.
Yeah. So I think the current sort of definitions are: you have a single round game, or you have an interactive verification game. So you can have a single round verification game, or like a multi-round one. An interactive verification game is much more complicated in terms of how that construction works. That's like Canon or Bold that you see with Optimism or Arbitrum. And then you have single round games, which are the ones that, like the ones we're designing, which are using a ZK, right, to basically just answer one question, which is like, is this block valid or invalid? So you just take the block, you run it through the ZK, and the ZK will just tell you, hey, yes, it's valid, yes, it's invalid. But you only need to use ZK when there is fraud, basically, or when there is a fault. So otherwise, everything progresses, optimistically.
Yeah, because the interactive games, they seem like wildly complex, and they include, can you just describe it? It's sort of very along. It's a game
Yeah,
essentially. It's accurate.
yeah, yeah. It's a complex game. So it's known as, and it was actually a mechanism created by a team a long time ago. What's it called? I want to say Trailer Bits, but that's the auditor. It's something Bits. So it was a mechanism created before actually Arbitrum and Optimism were doing this. Anyway, the main idea is that you're committing to what is effectively a piece of code, and you're running code in an environment very similar to like, or actually RISC-V or WASM, and you're running this sort of special interpreter. And what it's going to do is it's going to produce this sort of cryptographic evidence by way of actual Merkle proof commitments. The execution environment that we have is not only good for just executing blockchain computation in general, but it's also good for ZK, because even with ZK, you want to be able to get ahead of processing all the different bits that you possibly can find in advance, right? You would want to assign all those jobs to different GPUs or different things to produce those proofs anyway. So the Fuel VM is actually really good as well at getting ahead of a lot of the execution, breaking that up, and getting that into a place that it could be parallel processed in sort of a massive way. So in this sense, it's good for just general metered, optimistic, virtual machine execution, but it's also really good for being something that you can produce massive amounts of proofs for, like ZK. If that makes sense.
Yeah, I think let's just get more into like the philosophy of Fuel, because Fuel has been strangely ahead of a lot of things, and sort of these things I barely start to realize. Like, it just clicked to me like the Lightning logo was because it's an execution environment, and I was like, oh wow, like that's like a cool little detail. And so there's also the thing of like the exception of Fuel v1. I guess let's talk about Fuel v1, the philosophy of just where Fuel came from. So why is Fuel v1 the exception, and where did it come from?
Yeah, so Fuel V1 came out of us, like a very small Fuel team that we had, so 3 people, in early 2019. So we were developing it from middle 2019 all the way through to the end of 2020. And it was really to prove concept, both for the whole category of optimistic rollups, but also to show that Ethereum can have a different style execution environment entirely to the EVM and still be Ethereum. And so with Fuel V1, we wanted to not repeat the mistakes of the past, which were effectively the EVM. We didn't want to do that again, because the whole reason we're here in the first place doing rollups is because the EVM is so constrained by design. So we wanted to step away from that. We wanted to try something different. We wanted to actually have an environment that, again, took a lot more learnings from environments that we knew could be sort of easier to parallelize. So the Bitcoin blockchain itself, while using UTXOs, we realized that UTXOs are an incredible model for parallelism. So we incorporated that into our design. We incorporated segregated witness and some other aspects of Bitcoin itself, like hash time lock contracts. And we just wanted to show, hey, like this can happen on Ethereum. UTXO style system, completely different execution model, can use Ethereum wallets, can be on Ethereum, can be secured by Ethereum, can inherit the security of Ethereum, but basically be a much more parallelizable, robust execution architecture. And so that was really what Fuel v1 was about. With Fuel v1, I wrote all of it and built all of it. And the contracts were written in Yule. And actually, the entire rollups contracts fit into one contract. So it's very small. And that includes all the fraud proofs and everything else. We also didn't deploy it with multi-sigs. So it really does inherit the base level security of Ethereum. It's like very much a piece of Ethereum in that sense. So I think it's the exception because every optimistic rollup or ZK rollup wants to get to that place. They want to get to that place where it's really a true extension of Ethereum and Ethereum security. And that means that there isn't, multi-sigs that can upgrade it, tomorrow, or that there's like, anything in between, either the honest minority assumption that you add or the ZK assumption that you add. So you kind of want to get to a place where you either don't have multi-sigs or you have like a delayed multi-sig, such that the delay on the multi-sig is longer than the period, the withdrawal period, such that users can withdraw their funds if the multisig wants to do a crazy change. Basically, you can withdraw before that, sort of vote with your feet and leave, and that's sort of where we want to get every optimistic rollup to effectively.
And so Fuel V1 was only for transactions, right?
Transactions, and you could do swaps, like atomic swaps using HTLCs.
Mm.
But yeah, basically just transactions and swaps. Yeah.
And so what version is Fuel going to be at? Is it 2 or just stable release, or what exactly is this Fuel mainnet?
Yeah, so when we launch sort of the next major mainnet launch, that'll be launching our sort of next rollup. So you can call it Fuel V2. That's fine. We sort of call the architecture itself a rollup operating system, and then we call our next launch sort of the working title is Ignition, and that rollup will go live ideally this year. And the main idea there is that now we're bringing to the table not only all of our benefits around execution and performance, but we're also bringing our virtual machine, our language, our tool chain, a whole other set of new ideas to the Ethereum ecosystem. And it's with the hope of sort of, I think, completing a long journey that Ethereum has to become sort of this actual global transactional layer that people can leverage and that's like highly accessible. And so for us, we kind of see what we're doing with Fuel as sort of completing that idea. But yeah, it'll be a pure optimistic rollup onto Ethereum itself. It'll use 4844 DA. It'll use our hybrid proving model, and basically we'll hopefully get rid of the multisigs or have a delayed multisig with that deployment. Hopefully by like middle next year or something like that, if we can stabilize it.
This is also like a funny question, is that like Fuel has been in development for a long time. Why
Mm-hmm.
haven't you guys just just make the
Mm-hmm.
roll up without any fraud proofs with a multi-sig? Like that is the current standard for a lot of roll ups. It's just like, I don't even want to call it training wheels. Like sometimes the product just isn't there at all. Like it has no wheels in the first place. Um, why
Mm-hmm.
why why go through all of
Right.
this when you could just launch with training wheels?
So maybe I wasn't clear before. I think so. We are launching with training wheels. There'll be multi-sigs. There'll be a security council. The main reason that's actually taken us so long to launch isn't so much the security side of it, although that's important, and we will get to fraud proving. The main reason is actually because we've basically built everything from scratch again. So when you build a whole new virtual machine, a whole new language, and a whole new tool chain, um, you're basically starting from ground zero. So it does take a few years to kind of get your feet underneath you in terms of what exactly that is and how exactly that's going to work. And again, the main ideas there is that we plan on Fuel being a ideal option in the space of blockchain architectures that can remain both highly performant and sustainable. And that's as an execution architecture itself. So if you ran it as a layer 1 or if you ran it as a layer 2 or a layer 3, it would always retain these nice properties of sustainability and performance. And so we're targeting not just being a fast optimistic rollup, but one that is actually sustainable to run for a very long time and host millions or billions of users basically. So basically with UTXOs, what you're saying is hey, I have this sort of packet of coins that's attached to a specific address. And every UTXO is unique. So you know that every single one has a unique identifier and every single one can never be double spent. And because of these particular properties, you can infer the truth and the spending conditions and other things from all this information. And as you progress through processing these blocks and verifying them, these assumptions allow you to kind of reason with sort of binary reasoning that all these UTXOs are supposed to be in an unspent UTXO set. And all this means is that we can use UTXOs to our advantage to gain enormous amounts of advantage on parallel processing and on what we keep track of. And it can be all kinds of different unique elements in the system. So they can be unique state elements, like representing, say, a Uniswap pool, or they can be actual someone's coins, like their actual balance, right? And so you have like a sort of a wide diversity of things that UTXOs can represent. But because you can infer some more binary reasoning against them, and also with spending conditions that we put UTXOs against, those predicates, they're also binary, 0 or 1. They're either true or they're false. And so when you have that kind of system, it allows you to get ahead of so much processing and parallel process things in such a crazy way more than you can in an accounts model, way more than you can other kinds of execution designs. So we very intentionally picked that design because of all these incredible properties. Um, so that's just some reasoning you can say between, say, accounts model and UTXO model, why we picked it.
And that's what you talked about, the sustainability of just like the blockchain itself. I guess let's now talk about just how would you best describe fuel, or the language is called Sway. How would you best describe Sway sort of on a spectrum? Is it sort of like Rust, or is it sort of like Move, or just describe it?
Yeah, so maybe for just like, a smart contract developer, they've probably used Solidity before. So for a Solidity dev, I would describe it like this. I would say, have you ever thought, what if Solidity wasn't absolute garbage grammatically and syntactically and logically speaking? That would be Sway. So imagine if you went back, you cleaned up all the kind of structuring, the way that it works, knowing, say, how Rust is made, right? So it's kind of like bringing the nice things that Solidity has, like concepts of smart contracts, concepts of how the storage system works, right? Like how ABI works. Like you want to bring those concepts in as like a native piece of your language, but then at the same time, you don't want to bring all that baggage that Solidity brings, right? So we wanted to design a language that very much felt like Rust, but brought in all these nice concepts of smart contract languages. So Sway is very much a smart contract language. It is for building, and even more broadly in the smart contracts, because it does so much more than that. It's a blockchain language. It is for writing blockchain execution, and that has a lot of different meanings to different people. But it's basically just to say this is for building blockchain stuff, and it covers all the different kinds of things you would want a blockchain language to cover. And unlike Rust, even though it's very familiar and similar to Rust, Rust is a systems language. It's designed primarily to target hardware, or designed to target CPUs. It uses LLVM. It uses a complex tool chain to produce what it does. And while that's beneficial to target things like CPUs, it's not really a great tool to use for smart contracts. It's very cumbersome, and you have to band-aid everything a lot in order to get it to work the way you want. And it very much feels like not the right tool for the job, even though Rust is an incredibly powerful language, an incredibly powerful tool. So in that sense, it's very similar to Rust, but there's reasons why we didn't use Rust. And then lastly, with the language itself, I would say that Sway is meant to cover a wide variety of blockchain cases. So Move is very much designed for, say, just writing smart contracts and scripts, which is fine. But Sway is very much meant to cover all kinds of new sorts of paradigms that Fuel has, which are not just writing scripts and smart contracts, but writing things like predicates, writing things like indexers, writing things like deployment scripts. It's trying to save the developer an enormous amount of time and context switching, because it's really annoying to go between like 5 or 6 different languages to make a blockchain app. You would want to just ideally use something like Sway, and then something probably like for your front end, and that's it. So we want to very much make that a simple process for a developer. So that's really the direction of where we want to go with Sway itself, is to save developers an enormous amount of time as they code.
Mm-hmm. So Sway is opinionated. The only thing is that with like rollups in Ethereum, they all try to be sort of EVM adjacent or equivalent. And why did you guys take like the completely opposite approach? It's sort of harder to convince people to like use this new language. It might be better, but like people still like the EVM. Why go completely opposite? Because there's Arbitrum, that's EVM, Optimism, ZK Sync, Scroll, all it's almost like all of them. So why not the EVM, even though it sucks and like everyone agrees?
Yeah. Well, a few reasons. I think that if we keep picking the EVM all the time as the architecture and saying this is Ethereum, I don't think Ethereum will really compete or make it as a blockchain. So I think that unfortunately, if Ethereum wants to be a home for incredible amounts of throughput that the world is, demanding from a blockchain, Ethereum hosting only EVM execution environments is basically sort of a dead end, I would say. You want a wider variety of options. You want to give both Ethereum as a technology and also blockchain as a technology a few other options because we've well explored the EVM at this point. And I think that the EVM incurs a lot of debt from previous design decisions that were not so good, as we learned over the years. And as well, Solidity has incurred an enormous amount of tech debt. So, yes, it's always an uphill battle to basically bring something new to the market. I think the main idea is that if you don't do something different, you have no moat. There's no difference between what you're offering and everyone else. I would be much more afraid of offering the same thing in this space right now than offering something different. So for me, it's really very strategic, both for Fuel and for Ethereum, that we try something else and we try to solve problems in different ways because it'll probably end up influencing EVM design in the future. It'll probably, be more positive as an experiment for the entire community. And I think as well, it's just going to be way more fresh and exciting for a developer to pick up versus the same Solidity and EVM stuff that they're all used to, that they're probably pretty tired of at this point.
Yeah, I guess that comes perfectly into like describe the, I guess, Sway fuel ecosystem as of right now. Is it really all still like chewing glass? I just like describe the early programming language, early ecosystem process.
Yeah, so there's definitely some glass chewing that's going on right now, just because we're working at a lot of rough edges. Our aim is to make it far better as an experience than what you see in Ethereum, and it's way better already than Solana and other blockchains. So I would say that our aim is to make it a much better experience than what you would get with, say, Solidity and Foundry. As much as I appreciate their efforts in terms of what they've done there, it's extremely beneficial to everybody. We would try to aim at that as a bar, basically to say, hey, let's make this much more effective than Foundry. I would say that right now it is like chewing glass for a lot of the projects. There's a lot of rough edges. It's more fun when you can actually get everything running. That's what I'll say. There's definitely still a long ways to go in terms of our docs and examples and just kind of tuning everything. But I think that after a certain juncture, we will hit sort of an escape velocity with our concepts, our tooling, our language, the way that we do things, such that it'll be everyone else playing catch up to the work that we've done, and trying to emulate the kinds of things that we do with our developer experience. But it's not the case right now, so it's still a long ways to go. As far as what exists in the market right now, I would say that in the Fuel ecosystem itself, we've got a ton of projects doing tooling. We've got a ton of projects doing, a bunch of DeFi. There's an NFT marketplace. So, some projects to look out for is like Spark. They're doing an order book. They'll do an AMM, like a Uni V2. They'll do things like a Compound, that kind of lending system. Sail, that'll do things like predicate-based order books. Thunder, which is doing NFTs, or we have things like Baco Safe, which is very much like our sort of state minimized Gnosis Safe. And there's a ton of more projects coming, but basically we don't plan on having thousands of projects. We would just like to have a few really good ones that we can try to nurse into existence and make sure that that experience is really great, because there isn't really that many DeFi primitives anyway. It's maybe about 10 to 15 like max. So, if we can just cover those cases, then you've sort of well explored that. And the main thing for us is not so much that we want people to just come to Fuel and build whatever the Ethereum equivalent is. We want them to build things in a sustainable way. And that's what we call like the Fuel way. So there's like the Ethereum way, which is just sort of using smart contracts for everything. And then there's the Fuel way, which is trying to build the app, knowing how full nodes work, and trying to build it in a way that's like, if you scale this out to millions or billions of people, this would actually still be rather efficient. And so you don't want to be ignorant of that. Otherwise, you don't use a blockchain, just use a server. I mean, a server would be much better, than trying to retain all these properties of verification and state minimization, etc.
So a little detail. So there's can you explain the name Sway and Fuel? I know there's also like Ignite and then like the little execution logo. Can you just explain the little theme going on?
Yeah, so fuel comes from is a name I created that's is basically like an analogy to gas. So it was meant to sort of be a name that could come and supercharge Ethereum's execution, or supercharge the amount of gas that the what the gas on Ethereum could do, right, for the world. So in that sense, that's where the name fuel comes from. Sway comes from something else, which is basically that we wanted the language to actually be rather flexible in terms of how it works and what it does. So flexibility is one piece of it for Sway, but it's also just that like we picked the palm tree for the language itself, and it's because palm trees, like I don't know if you know, but like in hurricanes and everything else, even though they bend a lot, they're still there, like after all the storms and everything else. So they're actually an incredible structure that nature has produced. So both like the palm tree and Sway kind of fit this idea that we want to build a language that's for blockchain, but that is flexible and that focuses on flexibility. Really to save developers time and to make kind of better, safer programs. So that's why we picked Sway. And then the lightning bolt came from a few different things. I mean, we wanted to compete at the time in 2019 with things like Lightning itself on Bitcoin. So it was sort of like a bit of a jab at that, but also because it's execution, it's fast. We were trying to take a bit of a stab at Lightning in Bitcoin itself because we quite didn't like Lightning as a protocol. So, we thought Fuel really is like a response to that, but for Ethereum. But similarly, it's also because a lightning bolt's fast. A lightning bolt is for things like execution, right? These kinds of things. So it fit the tone at the time. But that was sort of our V1 logo. The V2 sort of logo that we have now is very much inspired by sort of like a floppy disk. It incorporates some of the lightning bolt and the F of Fuel all into one logo. If that makes sense.
Yeah, I think that was a really good overview. Love the vision. Is there anything else you wanted to add as we wrap things up?
Yeah, I mean, I would just say that I guess for us as a project, a key detail that's worth mentioning is um, the way that we build blockchains is very much about trying to build something that is going to last a long time and also something that's going to continue, I think, this ethos of design that we saw from Ethereum and Bitcoin as it started, which is very much that we want people on planet Earth to be able to run and verify their financial system and be able to actually have a vote and a say in that from home, which means that the design criteria that we work with is a more constrained design. It's one that considers, a crappier home internet connection, for example, one that can still do a lot of the throughput and be as accessible to as many people as it possibly can, but can also be something that people can democratically access. So retaining these properties of verification and accessibility for people is very important, I think, to sort of low node requirement blockchains like Bitcoin, like Ethereum, and Fuel carries that through. So it's not just about, with Fuel, building a fast blockchain. That's not that hard. You can write an Elixir server tomorrow or Rust server, probably be pretty fast. It's not about that. It's really about being very performant, but also ensuring that running these nodes and these systems remains something that doesn't require you to add a hard drive every 5 months and can actually be run and validated from home. So I think that that's something that maybe I just want to add. Yeah.
That's actually really good. I guess let's not talk about light clients. Um, what type of light clients are going to be on Fuel? I know like Solana sort of makes a lot of sacrifices with its light clients. I just talk about light clients. I love light clients.
Yeah. So everything in Fuel is designed with light clients in mind. And so every design choice we picked is basically along the lines of that. We want to make the block headers themselves as rich, from an information standpoint as we possibly can. So this means that the block design itself is very favorable to light clients analyzing what's happening. So with Fuel, we want light clients in everything. So ideally, all RPC requests are validated through light clients. Ideally, light clients are running every time you access fuel or you access fuel information, and you can gain some level of evidence or verifiability over what is being, given to you information-wise. But additionally, light clients and fuel can also do some really interesting things, like they can sample execution. They can basically provide you with, hey, is this UTXO spent or unspent? They can provide you with, hey, what is the state of a particular smart contract at a particular block, or what is a particular, say, execution trace, and we call a piece of that execution trace a receipt. So you can basically analyze a receipt route, for example, but from a block header. So you can go from the block header down to the transaction. From the transaction, you can then analyze a receipt route, and then from that receipt route, you can actually gain more evidence over what happened in each transaction. And by having a really rich system like this to introspect all these different pieces of the chain, a light client can provide a lot of clarity and certainty over exactly what happened with each transaction and exactly what state transition that you're looking at is actually is doing. So these are kind of the things that I think fuel light clients bring to the table. If that makes sense.
Mm-hmm. Another thing that's just like not thought about in rollups, and I guess like I also forgot about it till the end, is just like interoperability and composability. I know fuel is parallelized, so another thing is just like a lot of rollups don't really care about interoperability. They're sort of like an advantage to having your own ecosystem, or they're already scalable enough or already have parallelization like fuel. Just talk about optimistic rollups, fuel, and just interoperability in general.
Yeah, so interoperability ties into basically the idea of introspection. And just to say, and all that means is what kind of information can I attain cryptographically from something like a block header? So Ethereum block headers actually have a lot of information. The problem is they're really deep inside of different Merkle trees. And for you to introspect them, it's like crazy size Merkle trees, like 256 depths, right, of Merkle trees, just to get to like one state element, for example. So Ethereum, while it provides you with technically the entire state of the system by the block header itself, and that's great for introspection, unfortunately, most blockchains, they don't even have the room really to have people sending around these giant Merkle proofs. So they're not really great for actually interoperating or intercommunicating blockchains efficiently. They can, but it's hard. What you ideally want for blockchains is that they can all talk to each other. They can all read and see into each other. And in that sense, you would say it's interoperability. So ZK is actually really nice for some of these things. ZK is great at compressing these cryptographic Merkle proofs. So in that sense, it's great for compressing. It's also great if you had everything ZK, then basically you would have these succinct proofs to say, hey, this state is actually the real state of the chain. And this is the actual header itself. So ZK provides some nice facility here in terms of blockchains. Unfortunately, it's very expensive, as I mentioned, and even if it's 2x more expensive, still far more expensive than doing things in the optimistic setting. So with optimistic blockchains, making them interoperate, you definitely want to have a system where you can just say, hey, you know what? I think this event happened on Optimism, or I think this event happened on Arbitrum, or I think this event happened on Fuel. And you can interoperate them by providing this sort of evidence that's bonded and basically make that evidence something bonded or slashable, or by intercommunicating the headers together in such a way that you're saying, hey, I think this event happened at this header. And if it didn't, it's very easy for anyone just verifying any of those chains to go in and be like, no, that's not true. I'm not going to, counter that offer. I'm not going to respond to that. I'm not going to bridge these funds. So what Optimistic Rollups have going for them is that it's very cheap to run an Arbitrum node or an Optimism node to really see what the real truth is. The problem is when you want to prove that to another chain, or you want to prove that to Ethereum, maybe you can get away with proving like a light client proof, but it's not going to be maybe enough to like fully trustlessly or in a trust minimized way provide proof to a chain that like, hey, this is how it actually is. So in that sense, we have a ways to go to interoperate all these chains together. That being said, the majority of interoperation that we want is really just being able to move funds around in such a way that we can still, like I can go to Optimism to Arbitrum to Fuel and to Optimism, and it would cost me like pennies. That would be the most ideal case right now. And that I very much think we can make happen pretty soon by just integrating things like our Snap Finality gadget into those bridges. And there's probably other options as well, but just stuff like that will really significantly basically improve the chances that we can create this kind of system. So I would just say that there's a lot of great solutions coming for that. And interoperation is something that right now, actually, these teams sort of like the fact that there's a 7-day withdrawal and the finality is slower, and it's actually slightly harder because they get more users and they get more sort of capital stuck in their chain. I'm hoping we don't end up with that forever. That's sort of very much a temporary thing, I think. But yeah, right now that's definitely sort of the problem of our moment is just trying to get these chains to interoperate better. Yeah.
I'm excited for Fuel. It's probably one of the only rollups that feels special, feels unique. Is there anything you want to say, a shout out, call to action before we end things up?
I think the last sort of wrap up stuff would be to say, definitely if you want to build with us, if you want to sort of join our community, like, join our forum.fuel.network. We're always on it. We're trying to respond super quickly to queries, questions, developer questions, etc. We're going to be revamping all of our documentation. So we'll have sort of like a Fuel Bible that you can see all of our design philosophy, everything else. So that's coming up as well. We have, our Discord, which we're sort of revamping. It's unfortunately full of a lot of just like absolute degenerates. So we're gonna need to revamp the strategy there, but definitely join on the forum. And then as well, if you're into actually sort of breaking ground on a new kind of architecture, a new kind of system, just hit us up. We'll add you to some of our more closed off Telegram groups that we do our building in and everything else. And for us, unlike I think most architectures or chains, we're really trying to do everything the right way and do it, I think, in also a different way. So, with EVM, it's like, good luck deploying into the void of all the EVM apps, wherever that is. But with Fuel, if you design things the right way, you'll really stand out. And I think, it's an architecture to last another decade, not, another year. So for us, just know that that's where we want to take things. That's where we want to go, and still retain and hold things like Ethereum's values and Ethereum's design and structure, but bring that into a different competitive level, something that allows Ethereum or a system like that to really compete. So we really want to go all the way. And for us, we just welcome new people and new builders. That's really what we want right now, I think.
Thank you so much for watching. Thank you.